Okay, let's look at the homework 2.4, 2.5, problem number 13. All right, so we have function f of x, which is a piecewise defined function, and we want to find the values of a and b so that this function is continuous. Right? So you can see that each piece is rational function, quadratic function, and a linear function. So each piece by itself is going to be a continuous function. So only problem that could occur is between these pieces. So first one and the second one, and the second one and the third one. So it's going to be at x equals 2 and also at x equals 3. Right? So we want to make sure that the f is continuous at 2 and also continuous at 3. Right? So let's do that. Right, so in order to make sure that the f is continuous at 2, so we have to make sure that the limit of this function f of x as x approaches 2 is going to be equal to f of 2. Right? So first, to make sure that this limit actually exists, by looking at the left-hand limit, so limit of f of x as x approaches 2 from the left, right? So since it's approaching from 2, so from the left, so we have to use this first formula. So limit as x approaches 2 from the left, right? I'm going to go ahead and factor it out. So x squared minus 4 would be x minus 2 times quantity x plus 2 over x minus 2. Right? Then we can cancel common factors on top and bottom. Right? Then basically plug in x equals 2. So 2 plus 2 is going to be 4. Right? So this is left-hand limit. And a right-hand limit is going to be limit that f of x as x approaches 2 from the right. And since you're approaching 2 from the right, so we have to use the second formula. So it's going to be a limit as x approaches 2 from the right. And then you have this quadratic formula, ax squared minus bx plus 3. Right? So since it's a quadratic formula, you just have to plug in. So it's going to be 2 squared will be 4a minus 2b plus 3. Right? Then we just have to make sure that these two values are equal to each other so that the limit at x equal 2 exists. Right? So we have this equation. So 4a minus 2b plus 3 equals 4, right? Then I'll just go ahead and subtract 3 from both sides of the equation. So we have 4a minus 2b is equal to 1. So we can get one equation involving a and b, right? So we're going to make sure that it's continuous at 3. So we can look at the limit of f of x as x approaches 3 is equal to f of 3. Right? Just like before, let's make sure that this limit exists at x equals 3. So we're going to look at the left-hand limit. So limit as x approaches through 3 from the right, from the left, sorry. And you can see that we can from the left, so we have to use the middle formula. So we have a limit as x approaches 3 from the right, from the left, sorry. And you have ax squared minus bx plus 3. Right, so this is going to be plugging 3, so that's going to be 9a minus 3b plus 3. Right? And that's the left-hand limit, and which has to agree with this right-hand limit. So limit of f of x as x approaches 3 from the right. Right? So this is going to be limit as x approaches 3 from the right. Right, so it's approaching from the right, so we have to use this linear formula. So 2x minus a plus b. Right, so you can just plug in 3. So it's going to be 6 minus a plus b. Right, so we have to make sure that these two values are the same, so that the limit at 3 exists. Right, so you have 9a minus 3b plus 3 is equal to 6 minus a plus b. Right, so let's put all the a's and b's on the left and the numbers on the right. We can just let's see, subtract 3, then add a, subtract b. Right, that way you're gonna have, let's see, 10a and subtract b, so minus 4b is equal to subtract 3, so it's going to be 6 minus 3, so it's going to be 3. Alright, then what you can do is we can, let's see, multiply this guy by negative 2. So multiply this guy by negative 2. Right, that way you will have negative 8a plus 2b is equal to negative 2, actually plus 4b, sorry. Right, so that's going to be plus 4b. Right, and I'm going to copy this, so we have a 10a minus 4b is equal to 3. Alright, so let's add them up. Alright, if you add them up, you get 2a. Alright, so here's the key, 4b minus b cancel out. Then that's going to be equal to negative 3 plus 3 is 1. So we can simply divide through by 2 to find the a value. A value is 1/2. Alright, then we can just plug this guy back in here. So 4 times 1/2 would be 2 minus 2b is equal to 1. Right, so we can just subtract 2 from both sides, so you have negative 2b is equal to negative 1. Right, then we can just divide through by negative 2 to get the b is equal to negative 1 over 2 is just 1/2. Right, so a is at 1/2 and b is also 1/2. Right, so let's type it in. Alright, so a is 1/2, so I have to click on this. Alright, a is, alright, I can't click it. Alright, so 1/2, and b is also 1/2 in this case. Right, so let's check the answer. Alright, I came back and looks like we got both of these values correctly. Alright, that's it. I hope that this was clear.